In this video, we're going to do section 7.1, solving quadratic equations by root extraction and completing the square. Your book is a little bit strange because they call it root extraction, but it's really just what most books call the square root method. So if you've heard of the square root method, that's fine. It sounds a little bit better than root extraction. Root extraction sounds like something that would happen at the dentist or something like that. Alright, so there are several ways to do this, and one of the ways is to solve quadratic equations by factoring. So we have solved quadratic equations by factoring before, but I'm going to review that right now. So the first thing to do is to always set the quadratic equal to 0, and then factor out the GCF if there is one, and this one happens to be x, so it's x times 5x plus 11. Then set each factor equal to 0, so 5x is equal to 0, or 5x plus 11 is equal to 0. So if I subtract the 11, I get negative 11 and divide by 5, so a negative 11 over 5. Alright, so there are two answers there, 1 and 2. Alright, so that was a brief review of an easy one, as long as you remember to factor out the GCF first, but they're going to get more difficult. Hopefully not that much more difficult, you know. Alright, so let's look at number 2. Again, we need to make sure that we set it equal to 0, so I'm going to actually subtract the 5t and add the 6. Then I'm going to try to factor this if I can, and it's t minus 2, t minus 3, because negative 2 plus negative 3 is negative 5, and negative 2 times negative 3 is a positive 6. Then set each factor equal to 0. So if I add the 2, t is 2, and if I add the 3, t is 3. Kaboom! That all checks out. Alright, 3. This one is a little bit more difficult, but we have our a of 3, our b of 10, and our c of negative 8. Excuse me, so I have to multiply a times c, 3 times negative 8, to get negative 24. So I want numbers that multiply to give me negative 24 and add up to 10. So what would those actually be? It would be a 12 and a negative 2, because that is negative 24, and then 12 plus negative 2 is 10. So I'm going to rewrite this as 3x squared plus 12x minus 2x minus 8 is equal to 0. Then factor out the GCF of 3x. So I have 3x times x plus 4 and a GCF of minus 2. So minus 2 times x plus 4. Then I factor out the GCF of x plus 4. So I have x plus 4, 3x minus 2 equals 0. And I cannot forget to set each factor equal to 0, because if I do not do that, my cat will die. Alright, so by the way, I am allergic to cats, so that wouldn't be too bad of a thing to happen, right? So x is negative 4, or x is equal to 2/3. Again, if you have any questions about this, feel free to email me or write them down and bring them to the next class. Alright, but again, also, going back over these again would not hurt you as well. Alright, let's move on to number 4. So this is y minus 7 times y plus 5 is equal to negative 20. So this one, we have to actually do the FOIL method first, and then set it equal to 0, then refactor, and then set those factors equal to 0. So let's do that. Y times y is y squared, y times 5 is 5y, negative 7 times y is negative 7y, and negative 7 times 5 is negative 35, and that's equal to negative 20. Then combine the like terms. Y squared minus 2y minus 35 is negative 20. Add the 20 to each side. So y squared minus 2y minus 15 is equal to 0. Then I refactor this, and I need numbers that multiply again to negative 15 and add to give me the negative 2. And that looks to me to be a negative 5 and a positive 3. So then I set each of these factors equal to 0. So if I add the 5, I get y equals 5. And if I subtract the 3, I get y equals negative 3. Alright, are there any concerns about that? If there are, direct them to Lynn. Or you can send me an email or bring them to the next class. Alright. Let's look at the next one. Denise, are you doing okay? Alright, so what would we do when the quadratic equation is prime and cannot be factored? Well, this is when we have other methods that we can use, such as root extraction or the square root property. So if we have u squared equals 24, then I can simply take the square root on each side, but remember, when I take the square root of a variable, I have to use plus or minus, so u is equal to the square root of 24. Alright, plus or minus the square root of 24. Let's try again. Number 2. We're going to solve for x, so we're going to add the 49. Then we're going to divide by 5. And then take the square root to get rid of x squared. So x is equal to plus or minus the square root of 49 over 5. Now this is the part where some of you I know are going to have to practice. But square root of 49 over the square root of 5 is how this can be split up. But square root of 49 is 7. So I have plus or minus 7 over the square root of 5. Now some of you will say, well, I don't want the square root of 5 in the denominator. That's fine. You can rationalize it by multiplying by square root of 5 over square root of 5. And the reason why I need to do that is because 5 times 5 is 25, and the square root of 25 is 5. And so that makes the square root in the denominator go away. So this is a nice way to write your answer as well. However, again, for that reason, that's why I would normally just let you show this is your answer unless you really have a reason to rationalize the denominator. Alright, so hopefully that is all clear. And there aren't too many questions, so if there are, feel free again to ask me. 3. We're going to solve for the x, so we need to actually add the 7, then take the square root. Now remember, when we take the square root, we need to put a plus or minus, and then we need to subtract 3. And whenever I subtract the 3, I'm actually going to put it in front of the plus or minus sign, because I don't want to actually write something like this and accidentally think that the minus 3 is under the square root when it's not. So we always write this instead. Alright, so that is the final answer. Number 4. Solve for n. So I need to actually subtract the 121 and then divide by 9. On each side, so n squared is negative 121 over 9. Take the square root, so I need a plus or minus, so n is equal to plus or minus the square root of 121 is 11, but this is actually negative, so we have to be careful about that, because that means that we're going to have to just make this 11i. And the square root of 9 is 3, so it is actually plus or minus 11i over 3. Are there any concerns about this? Every time I try to put that 11 there, it is not going in here correctly. I'm about to give up on 11 for the rest of my life. Except for 7-Eleven. I kind of like their Slurpees. Alright. Let's move on to page 187. So here is completing the square. This is one of the hardest methods of all time. So please make sure that you pay very close attention to what I'm going to do here. I'm going to label all of the coefficients as A, B, and C. A is 1, B is 6, and C is 5. When I'm completing the square, I need to make sure that the number in front of the x squared is a 1. Otherwise, I'm going to divide out that number and get rid of it. Alright. So, here's what I do. I always need to subtract that number to the other side. So, I have minus 5. So, subtract the number, C. Then, I'm always, please keep this in mind, I'm always going to add B over 2A squared to each side. But I like to put it as 1/2 times B over A squared, just to be a little bit clearer of what's going on. Alright, so plus 1/2 B over A squared to each side. If you want to know where this comes from, please read the box on this page. But there's really no reason to know where this comes from. Just do it, please. Okay? Alright. So now, and actually, you know what? I want to be very clear on this as well. Alright. That, well, we'll come back to this issue. Okay, so now, this is going to be, if I substitute in my B, which was 6, and my A, which is 1 squared, and then I have negative 5 plus 1/2 times B, which was a 6 over the A, which is 1 squared. Now, I have 1/2 times 6 over 1. That is actually going to be 3. So that's 3 squared. And the same thing over here, 3 squared. Now, I can actually make that 3 squared into a 9, but then I have to refactor this as x plus 3, x plus 3. So my advice is not to multiply this out here, because whatever number this is inside of the parenthesis is what's going here. Alright. Then I have the negative 5 plus 9 is actually 4. So another way to write this is x plus 3 squared is 4. Then I can use the square root method like in the last section of problems here. So x plus 3 is plus or minus the square root of 4, but that is 2. Who is excited now? I hope you are. Okay. I see you, Rhonda. I can tell you're excited. Alright, so subtract the 3. And there we go. Negative 3 plus or minus 2. Remember, that stands for negative 3 plus 2, which is negative 1, or negative 3 minus 2, which is negative 5. So there actually are 2 answers here. Alright, well, if that weren't exciting enough for everyone, we are moving on to page 188. Alright, so here we have problem 3. I don't know where problem 2 went, but it's not here. Alright, so what we're going to do in problem 2, same thing. A is 1, B is negative 11, C is 30. Then I am going to subtract the 30. And then if you remember my next step, it was to add 1/2 B over A squared to each side. Now, substitute in my B, which was negative 11, and my A, which is 1 squared. And on this side again, and I missed the plus sign. The plus has left the video. Alright, so plus 1/2 negative 11 over 1 squared. So, again, I'm just going to simplify this inside. Negative 11 over 2 squared. Negative 11 over 2 squared. Now, remember what I said about this. You don't need to multiply this out here. I think I may have used the same color. I don't know. You guys know I'm colorblind. Don't laugh. You might be colorblind one day as well. You never know. Alright, so I have to use this number in here to factor. And because it's negative, this is going to be negative. So x minus 11 over 2 times x minus 11 over 2. Then here on this side, I have to do negative 30 plus negative 11 squared is 121. And 4 squared is 4. Then I need to find a common denominator. So I write the 30 over 1. And then multiply by 4 over 4 to get a common denominator. So this side over here is now x minus 11 over 2 squared. Then I have negative 30 times 4 is negative 120 over 4 plus 121 over 4, which is just 1 over 4. Hopefully this is all making sense. I know that you guys do not like fractions, at least everyone except Denise. I know you love those fractions, Denise. Alright, so now I'll take the square root on each side. So x minus 11 over 2, you need to remember the plus or minus sign. So plus or minus the square root of 1 over 4. But the square root of 1 is 1. And the square root of 4 is 2. And then add the 11 over 2 to each side. So I have x is equal to 11 over 2 plus or minus 1 over 2. And as before, remember that there are going to be two answers here. And one of them is 11 over 2 plus 1 over 2, which is 12 over 2 or 6. And the other one is 11 over 2 minus 1 over 2, which is 10 over 2 or 5. So we have two answers here. Alright, so hopefully everyone is okay with this and there is not too much struggling that is going on. Sometimes the struggle just definitely has to be real. Alright, let's look at number 4. I'm going to multiply each side by 5 to get rid of that 5 in the denominator. So 7x plus 1 is negative 5x squared. Then add the 5x squared to get this in quadratic form. 5x squared plus 7x plus 1 is equal to 0. But we have an issue. The number in front of the x is not 1. So remember I said from the beginning we needed to divide that out if it was not 1. So we have x squared plus 7 over 5x plus 1/5 is equal to 0. Then we do the same thing as before. So I need to actually subtract that number to the other side. So I get negative 1/5. Then I have my A is 1, my B is 7/5, and my C is negative. My C is actually the 1/5. So I guess I should have done that before I subtracted it. But we don't use the C anyway. Remember that all we use here is going to be the 1/2 B over A squared on each side. So C isn't even a part of this. Alright, so here we go. We know that B was actually 7 over 5, and that's over 1, so it's just 7 over 5. And then the same thing over on the right side. Right side, right time, right? Alright, so now let's simplify what's inside the parentheses. So 1 times 7 is 7, 2 times 5 is 10. Same thing over here. 7 over 10. Now what I'm going to do is actually factor this the same way as I have before. So this will be x plus 7 over 10. Where is that coming from? Right here. X plus 7 over 10. Where is that coming from? Right here. And then the other side I just need to simplify. So negative 1/5 plus 7 squared is 49. 10 squared is 100. Alright. So this is x plus 7 over 10 squared. But I need to find a common denominator, which happens to be 100. Why is this the same color? I know I'm colorblind, but I can tell that is exactly the same. Now it looks like somebody's lips. That's a horrible color of lipstick. Alright, I would never buy that for anyone. Alright. So now, negative 20 plus 49 is 29 over 100. Now it is time for the square root. But I need to remember to put plus or minus in front of the square root. And I know the square root of 100 is 10. Then I subtract the 7 over 10 on each side. So x is negative 7 over 10 plus or minus the square root of 29 over 10. Since there is a square root in the answer, I'm not going to actually go and write out the two answers. I think it just looks nicer like this. But the answers don't have a square root in it. Of course, it looks nicer writing out the two answers like we did previously. Alright, well I hope that you all really enjoyed this video about section 7.1.